Okay. 4.3, remainder and factor theorems. If you read this, it doesn't make a lot of sense, but I'll let you. You should write this down, try to make sense of it, but to help out a little bit, if we did 12 divided by 5, you'd get 2 with a remainder of 2. So this looks funny. This is what would happen. If you did 12 divided by 5, we would get 2, remainder 2. So 5 was what we were dividing by, our factor right here. So this 5 here, different color. This 5 is what we divided by right here. Our quotient from that, different color, was 2. And then our remainder right here, was 2. That's what that all means decoded. It still doesn't help. I'll let you pause it and write all this down. Here's something that's really important. The answer is 1 degree less than the original polynomial. Let's do one of these. If we took p of x, which is this big, long, ugly thing, write that down. Show that p of negative 1 is the remainder when p of x is divided by x plus 1. That didn't make any sense to you. That's okay. What they're saying is, if you plugged in negative 1 for x, you would get 6. Prove that when you divide, you get a remainder of 6. When you divide by negative 1 is a factor. So if negative 1 is the root, then x plus 1 is the factor. And a long division would be a nightmare, and it would look like this. Yeah, you're thinking, ew. And that's right. So, oh look, 6 is the remainder. 6 is what we got when we plugged in negative 1. It's a miracle. Not really, actually. This is going to happen a lot. Actually, I got a nice one of those. There you go. I'm going to leave that there. You should make sure your work looks a lot like this. And then we'll never do long division again. Long division's a nightmare. Here, look at this. F of negative 1 is 6, which is the same as the remainder. Neat. That always happens. Alright, back to these. Synthetic division. Quick. If you like writing down lots and lots of steps, this is it. This is our shortcut. You can write down all those steps, which probably won't make any sense at all. This is important though. If you're missing any powers, you have to use 0 as a placeholder. Same as with long division. We've done this before. Alright. Alright. These are the coefficients from here. Okay? And it says find the depressed polynomial, the quotient, when you divide by x minus 3. Well, if the factor is x minus 3, the root is 3. So you put 3 here, little box around it, and you add these together. 3, let's see, 1, you always put a 0 here. Let's write that down somewhere. Always 0. Always 0. Okay? 1 plus 0 is 1. Then you multiply by 3. This 3 right here. And you get 3. Add negative 1 plus 3. You get 2. Times 3 is 6. Negative 5 plus 6, 1. Times 3. You get 3. And negative 3 plus 3 is 0. Yay, that's the remainder. That's R. It's 0, so x minus 3 is a factor. So we can rewrite the original function, if we wanted, as x squared plus 2x plus 1 times x minus 3. Look, we're factoring. Look at us, we're so cool. Now this, we can factor again. We got lots of ways to do squareds. We could do it on the calculator, we can factor it, we can use quadratic formula, we can complete the square. This one's actually not too bad to factor. You know, x plus 1 squared, so that equals 0. There's a double root at negative 1 in there. Oh, you can't see that. All 3 of your roots are right there. Okay? We're going to talk about this tomorrow in class. You should come in knowing something. We're going to do this on Wednesday in class. Maybe I have another example here for you. There's your double 0. For a 0 of multiplicity 2. Neato. Check the graph of that. That's really important. Check the graph. You got a graphing calculator? Use it! That's not a negative sign. That's just a dash. Relative maximum at point x equals negative 1. That's fun. Okay? Good luck. Maybe this makes more sense up here now. That's a whole lot of mess. Ew. I like to put the box around the remainder. So that's x to the 5th, x to the 4th, x to the 3rd, x squared, x, the constant, and then a remainder. Oop, should be an extra thing here. Okay? Good luck. I will see you in class tomorrow, or you'll bother me before then. Have a nice day.